Okay, so we're ready to start. So thank you, ladies and gentlemen, for joining my presentation titled, Can Digital Twins Solve the Workforce Challenges of the Process Industry? So first of all, what workforce challenges am I talking about? So I think everybody of you knows that we have a generational change ongoing, and lots of experienced operators have already retired, and lots of new people have to be onboarded, and less experienced people are still in the companies who are able to train the young ones. And this is where our digital twin technology can help. Okay, so let's say assets are run by people, by humans. And there are numbers, so lots of causes, around 40% of the causes of the process upsets are caused by human errors. And also equipment failures, often malfunctions, often root caused by human error. So digital twin technologies we know today, often they treat the asset. So they try to optimize the asset by collecting data, analyzing data, by applying AI models, improving process parameters, and so on and so forth. So that's all dealing mostly with the asset. So what they fail to take into consideration is the interface of the human being with the asset. And this kind of digital twin, Gartner refers to as the discrete digital twin of the person. And that's also where Vuvio is, let's say, located. So we deal with this area. So in order to have a more holistic optimization, or holistic approach, you need to have inclusive digital twin model, which means you need to take into consideration both the asset as the human asset interface. So, without further ado, let's see a demo of what this digital twin of the person looks like. Okay, so what do you see here? We basically see a photo. It's a photo of a chemical plant. So in this example, it's a utilities plant. That's a customer example that we are allowed to show. And it looks like a photo because it is a photo, because our digital twin technology relies on photographs rather than 3D models of laser scanned plants. So you can just use a normal computer mouse, a cheap laptop, let's say, to run the program and to navigate through your plant. So wherever these green boxes appear, so these are so-called hot elements, so you can click on them and zoom in, and in most cases you can also do something with them. So these are basically the components that the operator can interact with, like turning a valve, for example. Okay, sorry. I think I'm still in the presentation mode. I have to. Okay. Okay, so this is how it looks like, the navigation I just said. So you navigate through the plant just using a computer mouse, or touchscreen even. And this is completely made of two-dimensional photos. So that's our proprietary technology that allows us to have this navigable environment made of photos. So here, these are the hot elements where you can zoom into the detail of each component and operate it in most cases. So these components, they are also listed, and you can search components by tag number, for example. And by using hyperlink, just directly jump to the location in the replica where this device sits. You can have a look at it, and you can also have a look around It's not an engineering tool, so this is not a tool that will measure your distances or be a tool for engineering purposes. It's just a qualitative look around in order. You can use it for discussions in your morning rounds, for example, rather than every time have to go out. So you can also enlarge this map view and get some orientation. Okay, whereabouts in the plant is this location? And so it is a help of finding components in the plant. You can also use this little avatar here in order to move in the plant. So just drag and drop. So you can, so wherever you have these white dots, you have a preview of how it looks like. You can go there, jump directly to that location, and continue to do whatever you want to do. Another way to move in this is by areas. You can also click on a different area to jump there. So many times we are asked, so can you actually simulate what's going on in the plant? I mean, it's not a process simulation behind, but of course we can simulate things like we call visualizations. We call it enhanced views. Let's say simulating what happens when we change valves, for example. So in this case, we can visualize the flows. We can visualize a lineup of valves. And I can use this to practice lineups, basically. So I can just play around with the position of the valves to change and see how the flow directions change. So this nice tool for instruction, and maybe, let's say, more instructive than just imagining a heart standing in front of the plant. So another example of such a visualization is this. Here we have just a visual representation of different flows. The background in this case was that the customer said, okay, in this location it's very noisy and very hot, so it's very inconvenient to have discussions on site just in front of that area. So we want to have something visual that we can use in a more protected space, in an office environment or in a meeting room. And so this is how this was realized then. Of course, this can not only be used for instructing operators, but this can as well be used as a help for doing risk assessments, for preparing work permits, for example. So what we just saw is a digital replica. This is the basis of our platform. So there's some nice features which can be used as standalone, but the core and the heart, let's say, of our tool is the procedure simulators. So what do we understand by procedure simulators? Imagine a pilot training flying. So he or she will use a flight simulator prior to really flying a real airplane. And why shouldn't we have something similar in a chemical plant where also the risk and the hazardous potential can be very high? So this is basically the idea, to simulate what the operator has to do and have him practice on the computer in the most realistic way possible. So let me show you an example. So we have here 5 different procedures. Each one has different levels of difficulty. Let's just start with a simple one. So this is the guide. It means it wants to be a virtual SME, so mimic the experienced colleague taking you by the hand and leading you through the procedure. So you get to know how the work is done correctly. So here on the right-hand side, again, you see the replica that we already know and the map. Here on the left-hand side, you see the standard operating procedure. So that's the original document provided by the plant. And here on the top, you see the action checklist. So the action checklist, so in order to simulate a procedure, you need simulable actions. And these have to be extracted from the standard operating procedure. So how does it work? So normally 2 of our engineers, they go on site, they go to the plant, and they form a team with an expert from the plant. So there must be somebody from the customer side who really knows the procedures in the plant very well and can answer open questions. Because what we often find in procedures is that there are ambiguities, there are gaps. So sometimes there are phrases like, okay, line up all valves, not saying specifically which ones in which sequence. So there's lots of room for interpretation, because the person that wrote the SOP thought, okay, they know how to do it. So, and this is something that we encounter very frequently. And so during this implementation process where we create this action checklist, we also gain a tremendous amount of procedure clarity, and we can remove ambiguities and therefore also eliminate potential sources of mistakes. Okay, so this action checklist is then the basis for simulating the procedure and also the basis for the training itself. So imagine I'm a new operator in the plant. I start with the entry-level module, which is this one. Okay, I have to start now by closing the drain valve 995, and I get a big indication where the valve sits and the tag, so it's difficult to miss it. It's really difficult to make a mistake. So I do it, and the system takes me directly to the next step. So here I have to check that this valve is open. It is already open, so it doesn't move. And what you see now coming out of this light bulb is a knowledge snippet. It provides some background information about why this valve always stays open. And this is a nice way to capture what we call tribal knowledge. So it may be like tips and tricks of people who are about to retire that you want to store, that you want to document. But it could as well be like safety alerts, like watch out, there was an accident in this location for this and that reason. Or you can put like video sequences explaining more in detail something. So you're free, let's say, to enrich the simulation of the sequence of actions by contextual information that is useful for the operator in that specific location. So as we are now here in the entry-level mode, so I'm not doing the navigation now. So the system also does this for me. So this has the desired effect that I don't only learn how to manipulate valves or what to do in the field, but also where to find the components and how to orientate in the plant. So which is important part of onboarding as well. So one of our customers made a trial. So he had some freshly hired operators who were experienced in operations, but not in that specific plant. And he had them train on Vuvio before letting them go to the plant. And their feedback was like, well, I had the feeling I've been here before. I already knew where everything was and what to do. So you can basically skip that very basic part of onboarding, of training, and people can enter the discussion and the training process with their experienced colleagues on a higher level, so they can directly go and ask, okay, why do we do it like this and not like that, rather than just asking where's the toilet, basically. So now we have different levels of difficulty with decreasing assistance by the system till we get to a test level or a self-test. So here the idea is to have conditions which mimic realistic, the real life. So there's no assistance by the system. I can check if I know what to do. So besides the procedure document, we find here a test report, which starts basically empty, and will fill when I do the test. So here now I have to know, okay, I have to look up here, and I have to know which one of these valves to use. So I can switch on, the administrator can switch on and off the tags, so you can make it easier or more difficult. Okay, so let's just pick this one. And now, as I've done the first step correctly, I get feedback that I've done it correctly. And now let's, just in the second step, just take the wrong valve, just take any other valve. And yeah, so I will get a big warning. I have the possibility here now to keep the mistake and just go on, or just try again as I remember what was a real valve. So, and now, okay, what was this here? Okay. So when I finished the test, I can go here on and get a automatically create a test report with an overview and the detail logs. And this is for the reference of the operator. So basically, he can discuss with his supervisor or whatever. So the idea is that here in this practice section, you can repeat the different modules of the training simulators as many times as you want. You can practice, and there's basically no tracking. So the operator gets to see his own training history, but not the supervisors. But of course, the supervisor administrator also has the interest of having a documentation of what's the qualification status of his workforce. And for this, we have this assignments area. So, so he or she can assign tasks, so modules to do to his workforce. And so the results of that will then be tracked and documented. And I will show you an example of what the analytics then looks like. Okay, so we have the possibility to show a very detailed breakdown, so who has done what and when and how many times and so on and so forth. So this is a breakdown that is quite popular on the other side of the ocean. In Europe, so far, we've encountered that most people, like depending on the country and the site, the company, prefer like an anonymized version, which is also perfectly possible. So you can just put here user 1, 2, 3, and only get to see, okay, who passed, who didn't pass, without getting all the details. So, so we can customize that according to the requirements of the site. So here we get to see a graphic analytics, so you get a very good overview of what's the qualification status of the workforce or the shift or whatever you defined the group. So there's some parameters that you can tweak. For example, here the passing score has been set at 80%. You can as well put it 90 or 95%, and you will immediately be able to see, okay, so what part of the workforce is qualified, let's say. And another analytics that I personally find particularly interesting is you get to analyze, so where do mistakes happen? And this is then a basis also for further improvements. So here in this example, so you have 3 mistakes at valve 904, and here in another action, it involves the same valve, again, several mistakes. So if you sum them up, it's quite significant. So it's worthwhile having a look at it. And when you click on this hyperlink, you can jump directly to the simulation, to the location where these mistakes occur. So you can there double check, so is there anything wrong with the procedure? Or you can check, is there any ambiguity, is there anything wrong with the action checklist? And you can also zoom in to the asset. And in this case, it was very obvious, I would say. So people confused these 2 valves. It was a mistake that not only happened in the tool, but also was reflected in the field. And so they decided to as a measure, let's say, to exchange the hand wheel of one of the valves, put a bigger one, put a different color, so to make it very obvious and prevent them to get confused, and could eventually eliminate this source of mistake. But of course, it's not always that easy. It's not always that obvious. So typical root causes for cumulative errors, maybe like the SOP does not reflect best practices, or the operator practice is not the same as the official practice. And in both cases, it's worthwhile, or it's good to have an indication where to look more closely. As a plant manager, you know that this happens, especially at night shift or at the weekends, that operators will take shortcuts, not always in compliance with safety rules, because it's faster or better or whatever in their opinion. And but you cannot always really pinpoint what it is in detail. And here you get some, let's say, valuable indications where you could look more closely and find room for improvement. Okay, so how is that reflect? So do we have any data to confirm what I just said? So we collected data from different customers, and here in this, what you see in this diagram is there was for each customer took like a critical SOP, a critical standard operating procedure, and did the test with operators that already were, let's say, pre-qualified, were already qualified, and had then practice with Vuvio for a month, and then redid the test. And what you can see is that not only the level of competence of the workforce, so the median has improved, but also the distribution is much more narrow. So besides the, let's say, the end result of qualification, what's also interesting is, of course, are you able to speed up the qualification? Can you speed up the onboarding process? Because as I mentioned earlier on, so nowadays we struggle with lots of fluctuation, so we have to hire more people, and they have to get productive faster than, let's say, 10 years ago or 20 years ago. And so one of our customers did a study on this topic just to check, is it possible to speed up or not? And what they found, so they for the study, they used a group of 25 new hires. So they already had operational experience, but not in that plant. And they did a 2-day study. So the first day, one group, so the group was divided into 2 parts. One part of the group was assigned to an extruder startup SOP using conventional methods like reading SOPs, looking at supporting material like P&IDs, and a field walkthrough with an SME, so a specific subject matter expert. And the other group got to train in Vuvio, and then had a short walkthrough with an SME. And the second day, they changed the SOP, took a new one, switching the catalyst pumps, and they switched the groups basically. So, and what they found was that the speed of the blended learning, so the combination of using Vuvio and having a short field walkthrough after that, the speed was significantly faster compared to traditional methods. But not only that, also the workload on the SME was significantly less. And the operators actually liked using it. So let me just skip these. I think we are running out of time. Let me just jump here to some. Maybe you can have a quick look at some of the comments that that we got or they got from operator side and also from trainer side. So the operators who actually got to use the tool, they said like they felt more prepared. And they found it engaging. So certainly reading an SOP is not that engaging. So that's you can just have a quick look. When we look at the trainer side, so they saw a noticeable difference between the two groups, and so the group that had used Wuvie before, they had more confidence when they came to the field. Yeah, so they saw a noticeable difference. Okay. So, have a look. So this is the current status of our as a customer base. So we started commercializing our software in North America. So that's why you see more going on here in the United States. We just recently last year started in Europe and Middle East. And yeah, if you are interested to learn more, you can come stop by our booth, number 44. I don't know if they have numbers on them, but it's when you enter the exhibition area, it's the second on the left-hand side. Thanks a lot.
Any additional questions? Maybe we can take one with respect to time. How long would it typically take to do such an implementation? Of course, I know that factories scale.
Yeah, I can talk of a typical project, which would not be a full implementation of the whole plan, but a partial implementation. Typical project that would be like a couple of days to 1 week of our people on site, and then between this, what we call photo shooting, and the final delivery of the product, you can count like 3 to 4 months.
Okay, thanks. Thank you, Susanna.